I'm Celine, an engineer at NI, here to show you our new ECU test system. This is a pre-configured automotive test system specifically for testing end-of-line and functional test of automotive ECUs and powertrain and body and chassis, those mid-complexity ECUs. And so it's a pre-configured test system designed to save you on development time. So it comes pre-integrated with all of the core hardware components you need in the rack. That's a PXI chassis for I/O and communication, SLC for signal conditioning and load management and E-loads, and also a Virginia panel mass interconnect. And so all of that's pre-configured. You don't have to spend time doing that. You can spend time on what differentiates you, whether that's building a test fixture or writing a test sequence or getting your integrator of choice to do that. Another awesome thing about this is because it's powered by PXI and test stand, we can do parallel testing. And so what you see here is I have two devices I am testing in parallel. That's two engine control units. And so we're going to be testing them, and there's some fault insertion we're doing in software, so it's kind of randomized whether or not they'll pass or fail, which is what I'll demonstrate for you here today. In software, we are running tests in test stand, and then we're using Instrument Studio to configure and manage those tests, Switch Executive to do that signal routing, and then LabVIEW as our application development environment that you could use the application development environment of your choice. So let's get started. So I'll start the test sequence. And you can see it running, and again, so I'm using our power supply, RMX power supply, to power the units. That's going through the SLC FIU module. I'm reading the 5-volt signal that we're expecting out. It's going through some switch matrix and then being read with the SMU. So that's kind of what's happening on the hardware side. And then if we look at our results, so we can see here that our tests failed overall, which means one or both DUTs failed. It looks here like DUT 0 failed because it was getting this much lower signal than the 5 volts we were expecting. And DUT 2 also failed because, again, outside of these test parameters we defined. Again, as you can see, those are tested in parallel, which is exciting. We're showing two DUTs in parallel here, but based on your pin count and requirements, you can test up to 4 nests, 8 DUTs in parallel with this test system. For more information on test system specifications and the details of the hardware inside, visit ni.com/ECUTS.